For a long time, concrete rehabilitation has meant traffic congestion and delays. But over the last few years, fast-track technology has allowed permanent, full-depth concrete repairs to be made and open to traffic in as little as 4 hours. As a result, the normal traffic flow is disrupted far less, especially if the repairs are made at night or between morning and evening rush hours. In this program, we'll take a look at the major considerations for early opening of full-depth concrete repairs. The details concerning construction methods can be found in the video program called Full-Depth Repair of Jointed Concrete Pavement and in the user's manual accompanying it. Many states have been involved in experimenting with and refining fast-track concrete technology. Today, even conventional equipment and techniques are being used routinely for fast-track repairs. Of course, a fast-setting concrete mix has to be used. But the real secret to a successful early opening project is to carefully plan, schedule, and evaluate the work. Let's start with planning. The first question is there a need for fast-track construction? The answer can be found by considering at least 4 factors. First, traffic congestion and delays on both the road to be repaired and any detour routes. Second, availability of alternate routes. Third, worker safety at the project site. And fourth, the possibility of expediting construction of the overall project. On a large and many-faceted project, only a small portion of the work may need to be fast-tracked to allow the entire project to be finished sooner. Once the decision has been made to use fast-track technology, the planning emphasis shifts to determining production rates for each activity. Finding and preventing bottlenecks in the construction process are essential on every early opening project. The first step in determining production rates is to be sure enough time will be allotted for sounding and marking all of the repair areas. Likewise, sufficient time has to be provided for full-depth saw cutting. Depending on temperature and slab condition and size, full-depth interior saw cuts may also be required. Because saw cutting is so time-consuming, all saw cuts should be made the day before removing and replacing the concrete. Plan on using multiple crews if necessary. Be careful, though, not to plan so tightly that more than 1 day can elapse between saw cutting and replacing the concrete. If the isolated slabs are exposed to heavy traffic for more than a day, excessive pumping and erosion can occur beneath the slab. Also keep in mind that saws are needed for joint construction after the repairs have been made. So, on large projects, you'll have to plan for double duty or additional crews and equipment. As for removing the concrete, always plan for the lift-out method. Not only is this the quickest way to remove concrete, it also leaves the repair area mostly undisturbed. To further speed up the process, the holes for the lift hooks can be drilled immediately after saw cutting. Of course, planning the number of slabs to remove per day depends on the production rates for pavement preparation and concrete placement, finishing, and curing. And that brings us to planning the next phase. Because all full-depth repairs will require dowel bars, it's essential that a gang drill be used to drill the holes. Along with speeding up the drilling process, this equipment helps ensure that all holes are accurately aligned. Another possible bottleneck to consider during planning is finishing the concrete. Although one crew can usually place and vibrate the concrete for all of the repairs, Several finishing crews may be required to keep up with the placement operation. One final concern during planning is contingencies. You may want to consider specifying standby equipment in case of breakdowns or suitable material to replace poor material discovered under the slab or anything else that will help keep the operation moving. Remember, the key to planning is to identify bottlenecks and prevent them from occurring. With the planning completed, the scheduling can be done. The emphasis here should be on the order and timing of events rather than on a day-to-day schedule. That's because the goal of scheduling is to arrange the work so that as one crew finishes an activity, the next crew can begin working. Schedules should be changed daily to allow for the amount of saw cutting completed. Slab removal should be stopped early enough each day to allow all subsequent steps to be completed. To make this decision, you'll have to consider the nominal curing time for the material being used, the productivity of the work crews, and the time at which the repairs have to be open to traffic. And that brings us to the last item on the list, evaluating the work. Fast-track mixes don't require any special procedures as far as placement, consolidation, and finishing are concerned. If the amount of available working time becomes a problem when using mixes with set accelerators, the admixture should be added at the job site to provide more working time. Other than that, your major concern will be with determining the opening time. Opening to traffic can be based on either curing time or in-place strength. The criteria based on curing time can work very well if the mix's strength development characteristics under the existing field conditions are well known. However, opening criteria based on in-place strength are more reliable. Both non-destructive and destructive testing procedures are available for determining the in-place strength of concrete. The non-destructive testing procedures include maturity monitoring and pulse velocity testing. Either of these two procedures can provide good results, but each requires a fair amount of preparatory work involving laboratory testing of the job mix to allow correlation of the non-destructive testing results to strength. And each requires instrumentation to perform the testing. The destructive testing procedures involve field testing of either concrete cylinders, which can provide either compressive or split tensile strengths, or concrete beams, which provide flexural strength. It is well known that the in-place strength of concrete at early ages is much greater than that indicated by field cylinders. Several procedures can be used to estimate the in-place strength of concrete repairs. These include temperature-matched curing boxes, insulated cylinders, and cores. Sharp field testing results showed that concrete cylinders placed in an insulated box provide satisfactory indication of strength gain in the repair sections. Flexural testing of 6-inch beams also provided good results. Full-depth repairs of up to 12 feet long can be opened to traffic without adverse effects when the repair strength reaches a third-point modulus of rupture of 300 psi or a compressive strength of 2,000 psi. And with that, we complete our discussion of evaluating the work, which brings us to the end of this program. Remember, the secret of a successful early opening project is careful planning, scheduling, and evaluating the work.